Good afternoon. Today we will learn the bleed-off circuit for the extension and for the bleed-off circuit for the retraction. Previously we have learned meter in circuit, meter out circuit. Now today we will learn bleed-off circuit and the regenerative circuit. Now here in case of a bleed-off circuit, now we will focus on the extension circuit only. So now I will zoom this diagram. Now this one is the bleed-off circuit for the extension. Now like each and every diagram here also, or a circuit here also, we need to begin from the reservoir. From the reservoir, focus on the central line. Pump is there, pump which is driven by the motor. Pump is pumping the fluid. Now here 4 by 2 direction control valve is used. Now pump P is connected to A side. A side is connected to A side of a cylinder. B side return to the B side of a DCV, and B is connected to tank, and here to the reservoir. Again PRV is there parallel to the pump and the return line. Now here how it work. Now here when pump starts pumping the fluid, here all the fluid is going inside the A side of a cylinder. Now this A side, it is also called as a piston side, and this is piston end, and B side it is also called as a rod end side. Now here to the A side fluid is present. Now here, now there are, if there is a load on the rod side, then what will happen? The pressure inside the A side increases. This increase in a pressure causes some fluid to be bypassed through a meter flow control valve. Now here flow control valve is there, which is attached parallel to the A to A line, and now here some fluid is bypassed. Because of this bypassed fluid, the speed of extension is controlled. That is why it is called as the bleed-off circuit for the extension. Simple thing. And in a return stroke we need to change the position of a DCV. Now if we operate this lever, then the position number 2 is going to take going to act. P is now connected to a B. Now this B, it is providing the fluid to the B side of a cylinder, and A side it is now connected to a tank. So here, now here also there are two ways for fluid. One is through the flow control valve and one is through A to T. But fluid always follow least resistance path. So all the fluid is going from the A to T and hence to the reservoir. So retraction stroke is a faster one and extension stroke is a slower one. Now here when extension is occurring, at that time pressure increases because of the load on the rod or load on the piston, and that is why some fluid is bypassed through a flow control valve. But in case of retraction, there is a uh, it follows the least resistance path, so retraction stroke is a faster one. Now we are having another circuit, bleed off circuit for the retraction. Now what will happen here? Now here let us check. Now here first in a position number 1, pump is pumping the fluid, it is going to the A side, or now here it is a piston side. Now here piston is moving forward, whatever the fluid which is present on a B side, it is returning to the reservoir. It is not going inside the through a flow control valve. Why? Because fluid follows the least resistance path. There is no resistance in between in this path, so it follows this path. So now forward stroke is a faster one. Yes, and now here name of circuit is bleed off circuit for the retraction. So in a retraction, the flow the speed should be controlled. Now we are operating the lever, and now here it is in the second position. Now P is connected to a B. Now when pump is flowing fluid, giving the fluid to the B side, now B side pressure increases and the some fluid passes through a flow control valve. So this flow control, so in a retraction the speed decreases. So this is the bleed off circuit for the retraction. Now what is this bleed off? Bleed off, you might have learned in a steam power plant bleed off circuit. Yes, some part of a steam is taken in between, so that is called as a bleed off. Yes, our veins are there. Yes, if some veins cut by any means, then our blood comes out. So in between the, if the blood is coming out, that is a bleeding. Similarly, in between, if we are taking the oil out, then it is called as a bleed off circuit. So this is the all thing about the bleed off circuit. Bleed off circuit for the extension, bleed off circuit for the retraction. Now we will focus on the next circuit. Now next circuit is the regenerative circuit. Now this one is the interesting circuit. Now in this circuit, now here generally 3 by 2 direction control wall is used, means 3 port and the 2 position. But here I have used 4 by 2 direction control wall. Now simple circuit, pump is there which is attached with the motor parallelly, pressure relief valve is there, P is connected to A. Now here rod end side is not connected to a B port. Yes, B port is closed. Now this is the, that is why we can use a 3 by 2 direction control valve. 3 by 2 means 3 port and the 2 position. Now here just we will focus on the working. Now regenerative, all these circuits are used for the speed control. So now let us check whether the speed is controlled or not. Now P is pump is pumping the fluid from the P to A. Now A side, now it is connected to both the end, to the piston end side, also rod end side. So what will happen now? Now on the both the side pressure is a P. On the both the side, whatever the pump pressure generated by the pump, P is there. Now what will happen here? Now we need to focus on the force generated by using same pressure P. So let us calculate the force. F1, how to calculate the F1? F1 is equal to P into A1, area of the piston, total area. If the diameter, capital D is the diameter of the piston, so we can write the force F1 as a P into pi by 4 into capital D square. Now what about the force on the rod end side? F2. F2 is equal to P into A2. Now what is this area A2 here? Now here area A2 is the area of a piston minus area of a rod. Yes. So if the rod diameter is a D, small d, then I can write F2 is equal to P into pi by 4 into capital D square minus small d square, which is the rod area. So now ultimately we are getting the F1 greater than F2. So what will happen? Piston moves into the right hand side. So what will happen if the piston moves to the right hand side fluid is again given to the piston side. So in the forward direction speed increases. Pump is pumping the same amount of pressure, but large amount of fluid is given from the rod end side to the piston end side. So the speed increases in case of a, now this is a forward motion. Now in case of a reverse motion, now here we need to change the position to the position number 2. Now this one is the position number 1. Now we need to, by operating this lever of a direction control valve, we are changing the position. So after changing the position, then P, now here A side is connected to a tank. So whatever the fluid which is present on a piston side, try to go inside the tank. So now here fluid is going inside the tank, and whatever the fluid present on the rod end side, some part fluid is going inside the rod end side and some fluid is going inside the tank, and this is the return stroke for the regenerative circuit. So this is the regenerative circuit and previous one is the bleed off circuit. Now you need to write down these forces also while writing in the examination. You need to write down these forces also, because this is the important in a working of this regenerative circuit. Regenerative, name itself is there. Regeneration of a force is there. Yes, by using same pump pressure, there is a regeneration of a forces, and there is a control of a speed of a piston, hence the speed of a rod inside. Now here we will stop. Thank you.